Hello and welcome to another video on variation. So on this video I'm going to cover just some examples with direct, inverse, and joint variation, just kind of writing a verbal description of it and writing the equation from a verbal description and just things like that. You guys were asking if I could maybe go through some more examples, so I thought I'd do that. So this wasn't taught in class. This wasn't assigned for homework. These are just more problems that I'm going to go through, okay? I'm going to assume that you watched the lesson video, okay? I'm not giving a full breakdown of these things from the start. These are just more examples to kind of get an idea of how to set up these problems, solve them, and all that, okay? Okay, let's start with the first one here. And notice I've got the equations up here. I do expect you to memorize those and know them for the exam, okay? Just make sure of that, okay? They're not really that hard to memorize, but just so you know. Okay. The time it takes to travel from North Vancouver to Hope varies inversely as the speed at which one travels. Okay, so I'm not even going to bother reading the rest of the problem because that sentence right there tells me what equation I need to write. So I'm going to call time t. I'm going to name it that variable. And it says varies inversely as the speed. You know what? I'll call that v for velocity, okay? Because speed, velocity, yeah, kind of like the same thing, except velocity just has direction. So let's set up an equation. Now it says it varies inversely, so I'm going to be using y equals k times 1 over x, right? But I'm using these letters that I've chosen. So it says t, and it says varies inversely. So that means t equals some constant k times inversely with velocity or speed. So it's this 1 over x business. That's 1 over v. Okay? And now I just need to solve the problem because you've got the general equation written. We need some information to figure out what k is. What is our proportional constant? We'll plug that information in, solve for k, and then we'll use that to make a prediction. So, reading the rest of the problem. If it takes 1.5 hours to travel this distance at an average speed of 120 kilometers an hour, find the constant k and the amount of time. So see, look, it says find the amount of time. So we know we're going to be solving for t. That it would take to drive back if you were only able to travel at 60 kilometers an hour due to an engine problem. So see, I initially drove there at 120, and the speed going back is going to be smaller, which means it's going to take more time. But first we need to figure out what k is. So let's say, okay, it takes 1.5 hours, so that's t equals 1.5 hours. I'm not really going to write the h. And the speed, velocity, was 120 kilometers an hour. Okay, you know what? Maybe I will. I'm going to say hours, and I'll say kilometers per hour. Okay? Okay, so we can use this information to find out what k is. Just plug in t. T is 1.5 equals k times 1 over 120. So I'll multiply 120 to the other side. That's 120 times 1.5. What's half of 120? 60. So k equals 180. Okay? All right. Nice. So now we just want to make a prediction with this. So I know that the equation is now t equals 180 times 1 over v. So if v equals, now it's 60 kilometers an hour, I ask myself, what is t? How much time does it take to go back if it's 60 kilometers an hour? Well, t equals 180 times 1 over 60. You know that that's just 180 over 60, and that's just 3 hours. Done. Done. And I might put a box around this too, just to say that that's my general, or that's my particular equation. Okay. By the way, this might be something I'd like to mention just real quick right now. There's sort of a difference between a general equation and a particular equation. So a general equation is, we just generalize what's the general formula. So like in this example, it was T equals K times 1 over V. But a particular means what is that particular equation for this context or this problem. So we would generally say that this is how you do these kinds of problems with time and velocity and blah, blah, blah. But for this particular problem, we found out that K was 180 times 1 over V. So if you ever see this word particular, you want to figure out what K is. If you just see general, it's just what's the general equation without solving for K yet. All right? Okay. Hooke's law states that the distance that a spring stretched supporting a suspended object varies directly as the mass of the object. That kind of makes sense, right? If I have like a little box hanging from a spring, if I have a heavy box, then that spring is going to be stretched out more than if I have a little tiny box like that, right? The longer the string, or the heavier the box, the longer the string is going to stretch. That kind of makes sense, right? All right. So this says direct variation. So it says the distance, I'm going to call that D, that a spring is stretched, varies directly as the mass, which I'm going to call M, of the object. So I say D equals some constant K times M. Yeah? Because that's direct variation. Okay. So if the distance is stretched 18 centimeters when the suspended object is 3 kilograms, what is the distance when the suspended mass is 5 kilograms? Yeah. So it's really is just plugging it in and figuring it out, right? So distance is going to be 18. We got to figure out what K is first. All right. That's pretty easy. Looks like K's 6. Oh, what a nice number that is. Usually doesn't work out that nice in physics problems. So K equals 6. Therefore, the particular equation is D equals 6 times M. And then it's asking what is the distance. So D equals what when M equals 5. So D equals 6 times 5. That means the distance is 30 centimeters. Do make sure you put your units there, okay? I know maybe some of you haven't taken physics or chemistry yet or whatever. Units are very important, and your science teachers are going to, at least I hope, they're going to nail that point, that you have got to have your units put there, all right? Now, me being a mathematician, yes, it's important, blah, 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 but I just really care more about the math. But you're going into science, yeah, you got to pay attention to units. My distance was in centimeters, so you better put centimeters there. All right. Okie doke. The wavelength of a radio signal lambda. Hey, shout out to Lambda Group. Yeah, Group Lambda. That's the orange table group in our classroom. Shout out to Lambda. Varies inversely as its frequency f. A wave with a frequency of 1200 kilohertz is okay. So blah blah blah, same old, right? It says lambda varies inversely, so I do K times 1 over, and the other letter is frequency f. Okay, and same old. It's just the same thing we've been doing, right? It says that the frequency is 1200, so I'm gonna say f equals 1200, and a length, hold on. Yeah, sorry. Wavelength of, I don't know what I was confused there. I don't know why I was paused. There it is. So I've got 250 equals K times 1 over 1200. So K is 1200 times 250. And what is that? I reach for my calculator because I don't want to do this in my head, even though it's really not that bad of a calculation. 300,000. Okay. K equals 300,000. Therefore, lambda equals 300,000 times 1 over f. And now it's asking, what is the wavelength when the frequency f equals 60? So it says lambda. So I say lambda equals 300,000. Essentially divided by 60, right? I'll just keep my calculator handy dandy here. Let's divide that by 60, and I get that lambda equals 5,000. What were the units for our wavelength? Meters. So it's meters. Done. Yes. And by the way, that is called lambda. Okay. So you see, it looks like that. Okay, that's lambda. Is called lambda. There you go. Okay, Greek symbol. Okay, a few more examples to keep going with this video. I think you may have gotten the idea by now, but I just thought I'd work a ton, okay? The centripetal force, F sub c, acting on an object varies as the square of the speed, v, and inversely as the radius, r, in its path. So when it says it just varies, the sort of assumption is that it's direct variation. If it was joint or inverse, it would, if it was joint or inverse, it would say that. Because see, it says inversely here. So the centripetal force Fc varies directly. So we're doing k times the square of the speed v. So this is v squared. And inversely, so that means we're going to divide it by the radius r. And it's not r squared, it just says r. Okay. Now it says that the centripetal force is 100 newtons. So Fc is 100 newtons. I guess y'all don't know what newtons are yet, huh? Well, that's what that capital N stands for. It stands for newtons. When the object is traveling at... Does traveling have two L's in it? Is it 2 L's or one? I don't know, actually. I guess it's 2 L's. Okay, anyway. Objects traveling at 10 meters per second. So V is 10 meters per second. And the radius is 0.5 meters. Okay? So we're going to use this information to figure out what K is. So that's 100 equals K times 10 squared. Because, right, the velocity is getting squared, divided by 0.5. Now, look, if I multiply the 0.5 to the other side, half of 100 is 50 times 100 times k. So then I divide by 100 on both sides, yielding k equals 1/2. Okay? All right, so the particular equation is F equals 1/2 v squared over r, or, Fc. Or Fc equals, you can actually throw that 2 in the denominator, v squared over 2r, okay? Because the half is in the numerator. And now it asks us to find the centripetal force when the object speed is that, and the path is this. So what is Fc when v squared is 25 squared divided by 2 times r is 1? Really? 1 meter? And I'm checking my units to make sure it's not like 1 centimeter or 1 kilometer. Be careful of that. So 25 squared, I don't recall what that is off the top of my head. It's 625. I thought so. I thought so. 625 over 2. So this is over 2. So this is 312.5 newtons is my centripetal force. Okay? Yeah. I think I did that right. Don't think I made any errors there. All right. Just making sure. Okay, last word problem here. Volume of a cone varies jointly as its height and the square of its radius. So volume, I'll call that V, varies jointly, so I get some K, times its height, H, and the square of its radius, which we call R, so that's R squared. Okay. If a cone with a height of 8 centimeters and a radius of 2 centimeters has a volume this, so look, just write that stuff down. V equals 33.5 centimeters cubed. Height equals 8 centimeters, and the radius equals 2 centimeters. Okay, we're going to use this information to find K. So 33.5 equals K times 8 times 2 squared. Running that little quick calculation there, that's K times 32. So it looks like K is going to be 33.5 divided by 32, which means K equals, let's take our calculator, 33.5 divided by 32 is 1.046875 is what I'm getting. You don't have to go that far with the decimals and stuff, but, you can. By the way, I'm kind of curious here. Yeah. By the way, that's pi over 3. If you want to take your calculator and do like 3.14 divided by 3, 3.14 divided by 3, you get 1.04667, because the sixes are repeating. So this is a very close approximation for pi over 3. Okay? All right. Anyway, we're not done. We have to figure out what the volume is. So volume equals 1 point. We're going to just use this approximation. Let's maybe just round this to, I'll do 4 decimal places. 469. Okay, you can kind of pick whatever. The more decimal places you use, the higher accuracy your result's going to be. It's fine. Okay, just kind of pick something. So this is volume equals this times the height is 6 centimeters and the radius is 4. And we don't forget to square that. So that's 1.0469 times 6 times 16. That's 96. So I take 96 times 1.0469 equals, volume equals 100.5. Honestly, that's fine. Centimeters cubed. I get like 0.5024, but whatever. It's fine. That's accurate enough, okay? All right, nice. There it is. So there are some word problems with direct, joint, and inverse variation. And some of those, I guess, were combined, like that previous one, yeah. So I don't know. Hopefully that helps with kind of answering some of the word problems. You can expect this level of difficulty on the exam, okay? We also are going to have some description of variation equations. So let's describe these in words. I noticed that in class, this is maybe one of the few things we struggled with more. And that's okay. You guys are doing this for the first time, you're learning. It's okay to struggle. So let's describe the variation for each equation. So this first one looks like K is my constant here. So we're just going to assume K is constant. This looks like an area equation. I don't know why else we would use A. Maybe it's amplitude or something, but I don't know. We're just going to say that A varies directly with what, right? K looks like your constant because we use K for the constant. So the variable is X, but X is getting squared. So we're going to say A varies directly with the square of X. Okay. And look, I know you probably say, why don't we just say X squared, Mr. Spake? Why do we have to write it as with the square of X? Well, I don't know, kinda. I don't know. It's just what everybody else writes. So I just kind of follow the math community on that regard. Okay. This is just how it's usually written. Okay, next one. So, and I might note, right, K is your constant. K is your constant of variation. If you're looking at the next one, so k, your constant, it's 1/3 pi. If you're kind of looking ahead at this, because pi is a constant, doesn't change, and 1/3 doesn't change. That's just a number. So I know that that's my constant, which means I have two variables varying with respect to volume, r and h. And since it's r squared times h, two variables jointly varying with volume. So I will say that I'm assuming it's volume because it looks like a volume equation, right? We don't actually know what these letters stand for, but we can kind of make an inference from it. V varies jointly with the square of r and h. Okay? Yep. V varies jointly with the square of r and h. Done. Now, if I look at the next one, h equals 3v over pi r squared. Well, your constant k is 3 over pi, right? You see that this is 3 over pi times v over r squared. I'm sort of separating the constant values in the equation from the variable values in the equation. So v and r squared are subject to change. 3 and pi are not. So that's kind of what my k value is. So I will say that h, which I'm assuming is height, h varies. Well, r squared is on the bottom, so that's inverse. And whatever's on top, that's going to be direct. So it's going to say directly with v, and inversely, varies inversely, with, you guessed it, the square of r. Done. Okay, one more example. I hope that these are helping. And here we go. So looks like the constant is k. So it looks like it's k times rm over t squared. I'm guessing, I don't really know what r is. Is that radius? Is that radius times mass and time squared? Is that the centripetal force maybe? Yeah, I don't know. Anyway, it doesn't matter that you don't know the context right now. You're just trying to describe the relationship between the variables. But we do know that k is the constant, okay? So I'm going to say that FC varies how? Well, it's Rm on top. So because it's on top, right? Look, whenever you got y equals k times x, right? That's on top, right? That's your numerator because it's not in the bottom. It's not in the right? The denominator is k times 1 over x, right? So if it's in the numerator, it's direct or joint. If it's in the denominator, it's inverse. Okay, I think that just kind of makes sense. I've got two variables again here, r and m. So it's not directly, it's varies jointly. I believe you could also say FC is in joint variation with, varies jointly with r and m, and varies inversely with t squared. Inversely with, well, not t squared, but the square of t. And there it is. Okay? All right. Hopefully those verbal descriptions help you describe these things. If it's direct variation, it's multiplying. If it's inverse variation, it's basically dividing. Yeah, it's denominator. And that's pretty much it. Okay, hope this was helpful. Let me know if you have any other questions. But these are more or less the problems you can expect to be on your quiz and exam. All right? All right. Catch you later, and have a good day.